All right, so this weekend lab is going to be the first verification quiz and interview, the first verification lab. So I've mentioned this like on day one, but there was a lot of information there. Now that it's much more relevant, I want to just kind of talk about how this is going to go down again, what to expect when you show up to lab this week. So it's, of course, the verification quiz and interview. What's going to happen is you're going to show up to lab. When you get there, the TAs are going to have a link for you for the lab questions. You'll go to that URL, and it'll have the 3 questions for the lab. It'll look very similar to the practice lab. If you're comfortable with that practice lab, you'll be doing good on this quiz. During the quiz, you shouldn't have anything open except the quiz itself. No browsing the course website or slides or whatever. It is a quiz/exam environment. No talking to other people, all that good stuff, all that, etc. The TAs will be watching and making sure that you're doing what you're supposed to do. And when you're, have slides open or something, they tell me that, and just don't do it. It's not fun. You'll submit the quiz on actual paper. The TAs will have all kinds of paper in lab, and you'll draw your memory diagrams, 3 memory diagrams on paper, and then hand that in to the TAs. There's no electronic submission for this. During the quiz, while you're taking it, the TAs will be calling out names. When the TA calls up your name, that means it's your time for the interview. The interviews will be 10 minutes, and they'll ask you, of course, questions about the learning objective. Once you finish the interview, you go back to your quiz. Once you're done with the quiz and interview, you're free to go. We're not going to hold you hostage or anything. So that's the logistics of how lab will go. And I get these questions a lot. I want to make sure that I'm very, as transparent as I can be, but I still, no matter how much I say it, I'll still get these questions sometimes. But I want to get the information out there. When you have a quiz or interview, the quiz is the read portion of the learning objective. The interview is the explain portion. When you get a quiz or interview, I go by these sentences in the syllabus for what that quiz and interview is assessing, what we're going to ask you, what's going to be on it. I don't flinch from these. I put a lot of thought into what's on these sentences, and sometimes I have situations where there's a question I want to put on a quiz, but it goes against my sense in the syllabus, so I don't ask that question, even if I want to. I hold to these. If you ever get a question on a quiz, well, you shouldn't get a question on a quiz, but if a TA asks you a question in the interview, or you do get a question on the quiz somehow that doesn't fall into these sentences, that's an invalid question. It's a broken question. Come complain to me, and I'll fix it on the grading side. We'll figure it out to make sure that you don't get negatively impacted by an unfair question that you didn't know how to prepare for. So for the quiz, trace through programs that trace the state of stack memory throughout their execution using memory diagrams. No surprises here. You're going to draw memory diagrams and put in the state. This includes stack frames, code blocks, variable scoping, all those things for memory diagrams. But I don't mention heap here. Don't worry, heap will come into play in LO2 in a big way. I don't put heap here, but there is a quiz question where there is an array, just like on the sample quiz, which goes on the heap. I'm not assessing your understanding of the heap at all. So when you get your quiz handout, the question that has an array on it, there's going to be a sample memory diagram that's already started for you that has this array already on the heap and a reference to that array on the stack. I'm not assessing your understanding of heap. Don't worry about the heap. I got you covered on the heap. I'm assessing your understanding of the stack. And pretty much everything about the stack I'm assessing, but only the stack. Same with the interview. You can read these explain portions for each learning objective and pretty much guess what the questions will be, or at least what the themes of the questions will be. Describe the concepts of stack memory, stack frame, variable scoping, and unit testing while reflecting on their importance in the programs we write. You can expect a question, what is a stack frame? What is stack memory? What is variable scoping? Why is variable scoping important to us? Can we have 2 variables with the same name in the same code block? What about stack frames? How do we test a method that returns a double? How do we test a method that returns a list when we don't care about the order of the elements of the list? All the things we've been talking about in lecture are pretty well covered by this sentence. Stack memory is the big one, which is broken down into stack frame and variable scoping. I want to be explicit. We're talking about stack frames and code blocks. Code blocks affect your variable scoping. How does it affect your variable scoping? Unit testing, what's the importance of unit testing? Why do we unit test at all? Those will be the types of questions. The interviews will be conceptual questions. So on the homework, on the project, and again, I use homework and project interchangeably. I'm sorry for the confusion on that one. But on the project, that's where I'm having you write test cases. That's your practical experience. That's where you're actually writing the automated testing. That's where I'm assessing you on that. So in the interview, I'm not going to say, like the TA isn't going to say, suppose I have a method that does this, give me 5 good test cases to test this method. Like that's not what it's going to be because that's what we did on the project. It's going to stay conceptual. Why do we unit test? How do we unit test in specific situations? Not specific like this method, but a method that returns a double. How do we test that? What's a truncation error? How do we handle that? Things like that. So that's what to expect. And again, learning objective 2, learning objective 3, you can pretty much guess what the questions are going to be like, at least the categories of questions that we're going to ask. So for example, on learning objective 2, the interview, you can bet we're going to ask about classes, inheritance, and polymorphism. Those will be the 3 categories of questions that we're going to ask about. And you should be prepared to answer those. I'm surprised how many people, I know I'm jumping ahead in the concepts a little bit, but for the learning objective 2 interview, how many students don't have an answer to what is polymorphism? I'm telling you exactly what I'm going to ask for that one. Now, after you answer what is polymorphism, if I say, give me an example of polymorphism, that might be a little trickier. But the TA is going to ask what polymorphism is. The TA is going to ask what a stack frame is. The TA is going to ask about variable scoping. So be prepared. Just understand those concepts. What isn't listed in these sentences won't be asked about. So, for example, Scala syntax, kind of implicit through the quiz, I guess. But in the interview, we're not going to. The TA is not going to say how do we define a function. We had 4 or 5 lectures on Scala syntax, but it's just not interview material. That again, I'm assessing that on the project. We're not going to hit you again on the interview. Kind of project and quiz, I guess, implicitly. We're not going to ask you again on the interview. Interview, we're going to ask you about stack memory, stack frames, variable scoping, and unit testing. Okay. Any questions about the quiz? Are we all feeling okay about this? At the very least, understanding the logistics. I don't want any surprises when you get to lab. I want everybody to know what to expect. Okay. And a quick reminder, this is the first round for a quiz, which means the learning objective, the read portion of the learning objective is on the line, but also an application objective for the quiz. If you don't get it this time, don't worry, you still have another chance on the final exam, away at the end of the semester, but just get it this week, you don't have to worry about that. The application objective, so there are 2 bars for a quiz. The learning objective, the read portion of the learning objective, and the application objective is you just say the LO threshold and the AO threshold. For quiz 1, just historically speaking, those are roughly the same. Oh, that's not the right way to word that. Very few students get the LO without getting the AO for quiz 1. You either understand these memory diagrams and understood the syntax and remember the syntax for the quiz, or you didn't. So get that AO that's on the table. Get that thing, go into that quiz ready, get that first AO on the books. Or second if you already got the project AO. Very few students get the LO without the AO. I said that right. The interview and the learning objective portion of the quiz, these are pass-fail. Geez, I almost forgot one of the most important parts. When you're taking the interview, your TA is going to be typing frantically while you're answering questions. Do not panic when you hear them writing. They're not writing like, oh man, this student, they don't know anything. That's not what they're writing. I promise you that. At least I damn hope. That none of my TAs would do that. What they're doing is annotating, transcribing your answers. So they're going to write the questions that they asked you, which will vary interview to interview, and a summary of your answers with as much detail as they can type during the time that you're talking. So they should be frantically typing the entire time that you're talking. They're transcribing your answer. So one feature that I do not want at all with these interviews is, oh, I got the easy interviewer, so I got credit. Oh, I got the tough interviewer, so I didn't get credit. I want to neutralize any differences between which TA you have as your interview TA. So what I ask the TAs to do, and what they do, is transcribe what went down in the interview, and then on the grading side, we neutralize the differences between TAs, at least the best that we can, and grade based on those transcripts. We read the transcript and decide, are these answers in enough detail to demonstrate an understanding of these concepts? If that answer is yes, you pass the interview. If it's no, then you got to retake it. And no big deal. We have, in week 6, 2 weeks from this week, is the second chance interview. So if you don't pass it, no big deal. Just study up and take it again in 2 weeks. And even if you fail that one, just use a recovery opportunity and take it a third time. But it will be pass-fail. They will be reviewed by humans with the grading team on the grading side of things by looking at those transcripts. So you want your TA to be typing as much as they can to get as much information to the grading team as possible so we can make an accurate assessment of what you know, of how well you answer those questions. If you pass the quiz, and we'll post those on Autolab after they're graded, we'll post on Autolab whether you pass the quiz and or interview. If you pass them both, there's no reason to go to the second chance lab. We got nothing for you there. There's also no reason to go to next week's lab, the review. We'll get grades out before the review lab so you can make an informed decision whether you want to spend 2 hours of your life reviewing something you already have credit for. You probably don't want to. But if you do, that's fine. But we'll get those grades out so you can make a decision. If you nail this interview and quiz, there's no reason for you to show up to lab for the next 2 weeks, 3 weeks, until LO2 practice starts. Okay. Any other questions on that? I think I got all the logistics out there. So since the interviews are pass-fail, do you need to answer everything correctly or just majority? Like, for example, if there's 4 interview questions and you get 3 right, is that pass-fail? So I don't have a concrete answer for you on that. It's all of your answers, all the transcripts come to us on the grading side, and we make an informed decision whether that's enough to complete the learning objective or not. I will say we're not super strict on the interviews. You can be fuzzy on a couple of the questions, and that's fine to pass the interview. But if there's like an entire section of the learning objective that you completely blanked on, like all of the unit testing questions, you're like, I don't know. Which I'm surprised, it happens quite often in an interview. A student will just say pass. And like if you're saying that for all of the unit testing questions, you're taking that interview again. But if you're kind of fuzzy on unit testing, but you nail all the variable scoping and stack frame questions, you get all that, I'm going to lean towards a pass on that. So it's pass-fail, but the bar is not perfection. You can make some mistakes and still get credit for it. Will there be a timer during the interview? They're 10 minutes. The TAs should be capping them at 10 minutes, but it's not like there's going to be a ticking clock that buzzes at 10 minutes. Like, it's not going to be that strict. But at roughly 10 minutes, if you're still interviewing. By the way, if you know all your stuff, a lot of the interviews for a student who knows their stuff inside and out, it's going to be 5 minutes or less for the interview. But if it hits that 10-minute mark and it's taken a long time, it's usually if you're struggling with the questions and things, the TA is going to say at 10 minutes, like, I have to move on. That's a practical condition. Each TA is going to have a long list of interviews to do, and they got to fit them in an hour and 50 minutes. They can, at 10 minutes with perfect turnaround, they can only fit 11 interviews in their schedule with absolute perfection, unless a lot of the interviews are 5 minutes, which I would like to see. But there are practical concerns there. If you need, I will say, when you need a recovery opportunity, I usually give more time for the interviews because we're scheduling time slots and everything. When do you know if you passed your interview or not? Before your next week's lab. My grading turnaround for any of my courses is always 1 week max. I want to get that, less than a week, but I won't strictly guarantee, but I'll nearly guarantee that you'll get grades within a week. And if you don't get grades within a week, at the very least, I'm really upset with some TAs and I'm yelling at them. So you should be getting everything in within a week. The TAs are aware of the deadlines. They know how to streamline things pretty well at this point. Can you use recovery? Using recovery opportunities on quizzes or interviews, those will be scheduled outside of lab. Okay. 20 minutes on logistics. Let's move on. Nobody's got questions. I might be the only one who wants to talk logistics. Could just open it. I already had it downloaded from the last lecture. What can you do to prepare for the interview again? So I'm not interviewing about Scala syntax, so the first 4 lectures won't really show up on the interview. But once we start unit testing and memory diagrams, those lectures would be your best resource. Yeah. This would this stuff? Yeah, it's in the syllabus. If you just go to the course website, you can see that for all the learning objectives. Let's do a memory diagram. Today I want to show you one last memory diagram. There are a few things I want to just clean up. Not necessarily memory diagram stuff, but just things that we haven't seen in a memory diagram. Namely, accessing characters and strings as though they were arrays. You saw this on the sample quiz. Spoilers, you'll see it on the actual quiz as well. So I want to make sure I cover that in lecture and show you all about it before we have any quizzes. And I'm also going to put 2 stack frames on the stack. Just a couple of things we haven't seen yet. Let's go through this example and do one more memory diagram. And then after this memory diagram, I'll briefly show the debugger. And then Wednesday and Friday, I'll show the debugger a lot. A very useful tool. I want to show you what that thing's all about. So we're going to set up our memory diagram. Split our diagram into stack and heap. Stack splits into name and value, and then some spot for our input-output. I know I'm not using the heap in this diagram, so I'm going to put input-output over by the heap, but just put it wherever you know you're going to have some space. We're not using the heap except for one array on the quiz, so you can safely put input-output over in the heap section and borrow space from the heap. But wherever you can get it, where it fits in. Okay, start with the main method. We're going to put a variable named word on the stack with the value dog. Hopefully this part is looking very familiar by this time. We saw this in quite a few memory diagrams. Please ask questions if you're still confused on that one. But I'm assuming at this point you're like, why do you still have a slide for a single variable declaration? Like, we get that part. So I don't have much to say about that one anymore. Stack frames, there's a bit more going on, so I still want to hammer this one down and remind you about stack frames. I have a method call. Whenever a method is called, we're going to create a stack frame and add it to the stack. On our memory diagram, we denote that with a solid box. We write the name of the method that was being called on the side of the box. And by the way, on your memory diagrams, you don't have to write these sideways. I'm just doing that for the slides because it fits that way, as long as you have the name next to the box here. And then an arrow pointing to where the return value is going to go. Now, in the memory diagrams I showed you so far, we were always declaring a new variable, leaving the value empty, and then drawing our return arrow to that. But the return arrow, in general, just goes to the variable where the return value is going to go. So in this case, I'm assigning it to the variable word. So I'm going to draw it to word. Even though word already has a value, this arrow says that value is going to be replaced by whatever this method returns. I should note there are certain things that our memory diagrams can't quite convey super well. And when we have those things, I'm just not going to show them in lecture, and I'm not going to put them on the quiz. So if you're wondering about certain things, like what if we had a method call as an argument here, how would we draw the return arrow? Well, I'm just not going to do that. Simple enough, right? There are a few things like that, like this as well. Storing a variable and then returning it on the next line instead of just having reverse of result. There are little things like that I'll do for memory diagrams specifically, just because it makes the memory diagram a bit more clear and a bit more clean. So we have our method call, solid box, name of the method, where the return value is going to go, and then any parameters. I have one parameter being assigned the value of the argument. Now I am going to skip the slide on the variable declaration. We declare a variable named result, give it the empty string. And I noticed in the previous lecture, I don't know if I'll update the slides, but I did miss a variable type declaration. Result should be a string. I said I'd try to not do that, but I did forget once already. So we're going to start our for loop, dashed box for a code block. Whenever we hit an open brace, we're thinking code block, as long as that open brace is not defining a method, in which case it's going to create a stack frame. Whenever we hit an open brace, we're going to create a code block, which is a dashed box. And since this is a for loop, we're going to declare the looping variable inside of that code block. So I created a code block for the for loop, initialized I to the first value that we're iterating over. And I'm going to start using this notation, well, I'm using this notation, this example, I should say, where I'm treating a string as though it were an array, which really is what strings are. A string is a more abstract, more complex data structure than just a string. Really what it is an array of characters. Technically in Scala, it's a sequence of characters. Sequence is an abstraction of any sequential data structure. So it could be a list, it could be an array, it could be any sequential data structure. But if we think of these as arrays, we'll be doing pretty good with that. So I'm going to iterate I from 1 until input.length. Until is exclusive of the endpoint. So I have 1 until input.length, which is 3. I have 1 until 3. It's going to exclude the 3, and I'm iterating over 1 and 2. Now, when I'm iterating over those, what I'm doing with that value is accessing the character at that index. Again, thinking of our string as an array of characters. A string is an array of characters, or a sequence of characters technically in Scala. So I'm going to access the character at index 1. So D would be the character at index 0, O would be the character at index 1, and G would be the character at index 2. I'm going to access the character at index 1, which would be the O, and concatenate that with the result, which is currently empty string, and reassign that to result using our shortcut syntax here, plus equals, which again is result equals result plus input of I. It's shorthand for that. We get to the end of the loop, so we loop back around since we have more data to iterate over. Update our looping variable. Whenever we update a variable, cross out the old value, write the new value. Cross out the old value, write the new value. And now we're going to do the same thing again. And here we can start seeing where the memory diagram is going to help us a little bit here. So we need to compute result concatenated with input of I. If you're just tracing through the code, it's easy to lose track of where you are and trying to figure out what's input of I and what is result at any given time. You have to trace all the way back to the main method to get all the information that you need if you're just looking at the code on the second iteration of the loop. It can be a bit mentally taxing to keep track of all that stuff. And this is a pretty small example. Once things get as complex as your project code, it's going to be almost impossible to think of, okay, I've gone through 100,000 lines of this program. Well, you wouldn't draw a memory diagram for that, but it's going to be a lot harder when your programs are more complex. So input of I, instead of looking at the code at all, I'm going to look at the memory diagram. Input is right here. I is 2, so I want the value at index 2 in this string. Value at index 2 in the string is G. It's pretty easy when I'm looking at my memory diagram. It's a bit tougher tracing through the code. You lose your place, you forget what the value of any one of those are, and you're tracing through the whole thing again to refresh your memory of what is going on. Or we can look at our memory diagram. It's G. We got it right there. And then we concatenate that, and then reassign it to result, cross out the old value, write the new one. We're done looping. We were only looping from 1 to 2. We hit the close brace. Once we end the code block, cross it out. We cross things out to say that that is no longer in memory. And technically, I did cross out my 2. You can't see it because I crossed out the whole thing with these big bold lines. But I crossed out the 2 and then crossed out the box. I don't care if you don't cross out that 2. It's not something I'm going to nitpick about. But technically, it's crossed out. But cross out the stack frame, or the code block for the for loop, because I is no longer in memory. If after this for loop I type print line I get variable not found and my program doesn't crash, doesn't compile. I can't even run that program. I is no longer on the stack. It's no longer in memory. It does not exist once we hit that closing brace. On the open brace, we started a code block. Any variables declared in that code block for loops, it includes the iteration variable, are destroyed when we hit the closing brace. They're no longer in memory. They're deleted off the RAM stick. They do not exist anymore. So we denote that by crossing it out off of our memory diagram. Then we hit this line right here. So we're going to call another method from inside a method. So we're inside a stack frame, and we need to create another stack frame. Now, most of this is going to be the same as when we're calling methods from our main method. The one big difference is we never draw a stack frame inside of another stack frame. We're going to draw it below the lowest part, the next open spot in our stack. That's where we're going to draw our next stack frame. We never draw a stack frame inside of a stack frame. This is, we're going to show it visually like this, never put a stack frame inside a stack frame, which is to demonstrate, to visualize what's actually happening in the computer. each stack frame is in complete isolation of each other. We're not going to draw them inside each other and pretend that they're nested or anything. They're not nested. They are completely independent structures of each other. They're different sections of the stack entirely, not just in our memory diagrams, but in the computer and RAM, on our RAM sticks, on our actual silicon. They are separated. They're separate sections of memory. So we're going to show that visually so we're accurately showing what's happening in memory. They are isolated from each other. The only thing that connects stack frames is return values. And foreshadow a little bit, the heap is going to connect our stack frames a little bit too, in different ways. But on the stack, the only thing that connects our stack frames are the return values. So we're going to add another stack frame completely independent of our other stack frames, solid box, name of the method, and draw the arrow of where we're returning to. The arrow just points to whatever variable we're returning to. In this case, result in the modify stack frame. And that's how stack frames are communicating, through return values. The stack frame is going to return to result. Other than that, they're completely independent of each other. And the arrow just straight up goes to wherever you're returning. Eventually, we'll see return arrows that go to the heap. If we said, like some array of 1 equals this method call, we would throw a return arrow over to the heap. I'll save that for LO2. But return arrows go to wherever the return value is going to be stored. And again, I'll always store that in a variable, just to make our memory diagrams more clear. In memory diagram examples, anyway. Then we keep going through this next stack frame, just like another method call. Our input, our parameter is assigned the value of the argument. We're putting result on the stack, variable declaration, hit our for loop, get our iteration variable on that stack, in that stack frame. And our stack frames are what's really using the data structure of a stack. Our stack memory really is a stack of stack frames. And I know we draw these, going down, but I would say this is the frame on top of the stack or on the bottom of the stack visually. That's always going to be the active stack frame. Whatever stack frame is lowest on our diagram visually, that's not crossed out already. That's going to be the active stack frame or the currently running stack frame. And that's the only variables that can be accessed at that time in that program. This modify stack frame, it's still on the stack, but it's inactive. It's sitting right here waiting for this call to reverse to return. And once it does, once that stack frame for reverse returns and is destroyed, removed from memory, then this modify stack frame is going to get control of the program back again. It will be the active stack frame again, and it can continue what it's doing. Once it's done with what it's doing, it can hand control back to the main stack frame, which we don't draw our box around our main stack frame, but it is a stack frame, just to clean up our diagrams a little bit. It is a stack frame. Main is sitting here waiting for modify to return. So once this stack frame returns, it's going to give control back to this stack frame, the main stack frame, and it can continue what it's doing. So we have a stack of stack frames, and only the frame on the top of the stack conceptually, the bottom of the stack visually, is the active stack frame, and once it returns, we just go back to the next stack frame on the stack. And this is how your program keeps track of where it was. When this reverse method returns, where do we go back to? Well, the previous stack frame, and the previous stack frame remembers where it was, what it was waiting for. Start looping. We're going to update result. I is iterating over the indices of the input. So this is just like we did with arrays. We can use dot indices. Iterate over the indices. I don't have too much to say about that. But the indices for this string, index 0, index 1. So we're going to iterate over those indices. So I is going to get the value 0, and then 1, and then that'll be the end of the loop. So we're iterating over all of the indices of this string, just like if we said iterate over all the indices of this array. Same idea. And we're accessing values using the same syntax like we did here. I think I forgot to mention it here. But we're accessing it by saying input of some index that's going to give us the character at that index. Input of 0 is O. Update our iteration variable. And here we need to make sure we pay attention to the little details. The little details will really frustrate us in this game if we're not paying attention to them. Input of I, input of 1, that's going to give us G. And we got to pay attention to the order in which these things are being concatenated. This is actually pre-pending characters. So we're going to get the characters reversed. Well, I guess the name implies it here. But we're going to get the characters reversed in this string because it's input of I plus result, not result plus input of I, not result plus equals input of I. It's going to be input of I plus result. So we want to make sure that input of I, which resolves to G, plus result, which at the time was O. So G concatenated with O to give us our go. Some little details. Very important to pay attention to in this game, in programming. For loop ends. It's no longer in memory. And the stack frame ends and returns. So we're going to cross out this stack frame. When we cross it out, that means it's no longer on the stack. It's no longer in memory. It doesn't exist anymore. In fact, if we called another method here, it would reuse the physical location of that old stack frame. It's completely erased from memory, and that memory is free to be used by other variables and other stack frames. This is no longer in memory. So the active stack frame is always the lowest stack frame visually that's not removed. This one's removed, so modify is our active stack frame again. It's going to store that whatever was returned in result, cross out the old value, write the new value, and return it. We're going to return result. That goes back to the main stack frame. Cross out this stack frame. It's no longer in memory. We only have one stack frame left in memory, and that's the main stack frame. It was waiting for its return of modify to store it in Word. Cross out the old value, write the new value. And don't forget to print it to the screen. Print to the screen. Forgetting to write your outputs, what's printed to the screen, it's a frustrating and silly way to lose an application objective. That is a major part of these memory diagrams. Like that's really what this program actually does in terms of from the perspective of the user. Somebody running this program, it just prints go to the screen. That's all you see from a user perspective. It's a very important piece. Just don't forget to put them. Sometimes, I can kind of assume that you just forgot, but that's a big mistake. That's one that can cost you an AO. Yeah.
So for the input output.
The quotes around it? No. If you put quotes here or not, I'm fine either way. I'm not gonna nitpick about that. Either way you want to do it. So whether you put them or not, to me, it doesn't reflect your understanding of how stack memory works. That's what I want you focusing on here. I don't want you wasting brain power memorizing, wait, did he say put quotes or not put quotes? I don't want to play that game. Just understand how the stack frames and code blocks, variables, return values. I want you to know all that stuff. Then our program ends. Any questions on this example? Okay. I'm going to take that as a no. I want to spend like I said, I'll do more debugger Wednesday and Friday. I I want to make sure I spend most of this time on memory diagrams because that's what you're about to be quizzed on in lab. And then I'll spend more time doing debugger stuff for the rest of the week. So, let me get this back and have it set up from the previous lecture. Let me clean that one up. And we'll go through the same example, which I got to show something different in the other lecture. But this example, if you have the examples repo, which you all should have it cloned on your machines. You went through lab on week 2 to be able to get this cloned. If you don't see this example, which you probably won't because I just pushed this a few hours ago, click this poll button, like, it was in the lab, but briefly. Push this poll button. That's going to pull all of the latest code from GitHub, and you should see that example just pop up. It should appear there. So if you don't see an example in general, if I have an example in lecture, and you don't see it in the repo, hit this button, pull the latest code, and you should be able to see the example. If you don't, let me know, because I forgot to push it. So just let me know if you don't see one. Okay, so I have this program. I'm going to run it. It should print go to the screen, and that's all the information we get. This is a lot of unit testing too. You run your unit tests, you get very little information. Like if the test passed, that's all the information you need. One bit of information, they passed, cool. I'm good with that, and I'm moving on with my life. If a test fails, I might need a lot of information because I got to figure out what went wrong. You can use your hint text in your unit tests to be able to get some information. You can print out the inputs and the outputs and things like that and get some information. But that's a lot of times not enough. So we want to run what's called the debugger, which is going to show us the state of memory as our program runs, and it's going to let us run our code one line at a time and watch memory changing. This is also a good way to test your memory diagrams if you want to practice for the quiz. Get a piece of paper and a program, draw out what you think the memory diagram should be, and then run the debugger and see if the debugger agrees with you at each step of that program. So what's the debugger? Let's do this. So we're going to do this in 2 steps to run it. First, we need to set what's called a breakpoint. For now, I'm just going to set it at the first line of main. If you want to run a program with the debugger, set a breakpoint on the first line of main. To do that, you'll click right next to the line number, and you should see this red circle. That means you have a breakpoint on that line. And then we're going to run this using the debugger. So instead of clicking my go button, I'm going down one and saying debug. And what this will do is run the program until it hits a breakpoint. Once it hits a breakpoint, everything stops, and it's going to show me a snapshot of everything that's in memory at that moment, at that breakpoint. So I set a breakpoint on the first line of main. For what it's worth, it'll stop before that line is executed. So I can see what's on the stack. This is going to be the current stack frame, all the variables that I have. I have a reference, the string examples. That's something we won't worry about in our main methods, and we won't really talk about in our other methods until LO2. So we're not messing around with that yet. And then args, something we don't mess around with this class, but the parameter for the main method. So these 2 things wouldn't go in your memory diagram, but they are on the stack. The other thing it gives us is all of the stack frames, which I'll talk about when we have more than one stack frame. It's not as interesting yet. Each time we, let me back up. This button is my favorite button on the debugger. This is going to advance one line and step into any method calls. It's called the step into button. I pressed it and it advanced my program one line. So we executed this var word of type string equals dog, and I can see that variable on my stack. I have a variable named word with the value dog. I'm going to push it again. We have a method call. So this is going to go into the method call. Creates a new stack frame, and this is our stack of stack frames, which does show visually the top frame. The active frame is on the top of the stack, so it matches the concept of a frame, of a stack. And we see that we have input equal to dog, again, we have this. This isn't something we're worrying about until we talk about LO2. Don't put this on your memory diagrams yet. Input is equal to dog, and we can switch our stack frames. We can go back to the main stack frame and see what was on that stack frame at this point in time, go back to our modify stack frame, and see what each one of them, what all the variables are in each stack frame. They are completely independent. Each stack frame is completely independent of each other, and in the debugger, it denotes that by only showing you one stack frame at a time. They're completely separate. They're not nested, none of that. They're completely separate entities in the stack. We're going to get to our loop. And here we're going to start seeing a few quirks of the debugger. It's not as perfect as I would like it to be. We declared a variable named result, and it doesn't really want to tell us any information about it. It's an empty string, and for some reason, the debugger just doesn't know what to do with it. And now when I click advance again, I have multiple method calls on the same line, and the debugger is going to ask, which method do you want to step into? I don't want to step into any of those. So I'm going to click it again, and for some reason it skips the entire for loop, which isn't quite what I want. Whenever it's skipping code like this, set another breakpoint inside your loop. I'm going to click this button to rerun the debugger. It's going to stop at my first breakpoint right at the start of main. And I'm going to use this resume button. This is going to continue the execution of the program until it hits another breakpoint. So I get to go to the first iteration of my loop. I can see I equals 1. I'll step forward. I equals 2. Result does have the information that I want. But for some reason, it's showing me the ASCII values of the characters in there instead of showing me the strings. So there are little quirks like this where it gets a little frustrating to work with. But it is still a very, very valuable tool, even with the quirks. I go into another stack frame. I can see I have 3 frames on the stack. I can go hop across them, and I can continue going through my program. And that's all I have time to show today. But we'll explore the debugger a bit more in future lectures. And have a great day. I'll see you Wednesday.